I'm working through question 3 of the 2019 chemistry paper. This question focuses on organic chemistry and more specifically on physical property relationships. This is section 2 of organic chemistry, and question 1.1 in this paper also refers to section 2 of organic chemistry. Question 1.1 reads, which one of the following compounds has the highest vapor pressure? Now we know that vapor pressure is inversely related to intermolecular force strength, which means that this question is actually asking which of the following compounds has the weakest intermolecular forces. And so what we can see here is we can see that we have a number of compounds with different functional groups. Here we have a carboxylic acid. CHO represents an aldehyde, an OH represents an alcohol, and here we have an alkane. Now we can see that the alcohol, aldehyde, and carboxylic acid are all polar molecules, or all have a polar bond in their functional group, and as a result would have dipole-dipole intermolecular forces, whereas option D, the alkane, is non-polar and therefore would have the weakest intermolecular forces and therefore the highest vapor pressure. Question 3. The boiling points of 5 organic compounds, P, Q, R, S, and T, are studied. Here we can see what these 5 compounds are, and what we can see, or what I would suggest, is that you start by drawing each of these compounds. The first one being pentanol, meth, eth, prop, but, pent, and pentanol tells us that this is an aldehyde which has a carbonyl group on the first carbon. The second one, 2,2-dimethyl-butane, butane, meth, eth, prop, but, and 2,2-dimethyl tells us that there are methyl groups both on the second carbon. 3-methylpentane, meth, eth, prop, but, pent. 3-methyl tells us that there's a methyl group on the third carbon. Hexane is a straight chain alkane. And pentan-1-ol is an alcohol, meth, eth, prop, but, pent, with an alcohol or hydroxyl group on the first carbon. Question 3.1, define the term boiling point. This is the definition as given in the syllabus requirements, and that is the temperature at which the vapor pressure of a substance equals the atmospheric pressure. Important here that this is not the definition, or the definition is not the point at which a liquid becomes a solid. The boiling point refers specifically to the relationship between vapor pressure and atmospheric pressure. Question 3.2, the boiling points of compounds Q, R, and S are now compared. Question 3.2, give a reason why this is a fair comparison. And what we should be able to see here is that in compounds Q, R, and S, they are all alkanes. There are only carbon-carbon single bonds, and they are all alkanes. And because they are all alkanes, they will have the same intermolecular forces, those being London forces. So these are all alkanes. As a result, there are only London forces present, and as a result, the only thing that we are actually comparing is the chain length and the amount of branching between each of these molecules. Question 3.3, the boiling points of Q, R, and S are given below, not necessarily in the correct order. And the 3.3 then reads, which one of the 3 boiling points is most likely the boiling point of compound R, and explain the answer. The first thing to do here is that we must point out what intermolecular forces are present in each of these molecules. And now, as we have pointed out in the above question, where we said that they are all alkanes and therefore all have the same number of carbons, and have the same number of carbons, we can see here that compounds Q, R, and S are all alkanes. And because they are all alkanes, they will all have London forces that act between these molecules. So that is the first mark would be allocated here for indicating that all of these three compounds are alkanes, and because they are all alkanes, they all are non-polar, and therefore we would be dealing with London forces. The next step is then to identify that compound Q has the most branches. Because as we can see, compound Q has 2 methyl branches, where compound S, hexane, has no branches, or the fewest branches, which then leaves compound R as between those two with 1 branch. What then becomes important is that we indicate what the meaning of that is. So we say because compound Q has the most branches, we would say it has the smallest contact surface area. Contact surface area here refers to the number of sites where bonding can occur. And so we say the smallest contact surface area, basically saying that because this compound has more branches, there's not as many places where these London forces can occur. And then by contrast, S, which has the fewest branches, will have the greatest contact surface area, and therefore will have the strongest London forces that exist between it. So that would be the second mark that's allocated here. The third mark would be for relating this to an energy. So we would say here either that because Q has the smallest contact surface area and therefore the weakest intermolecular forces, we say Q requires the least energy. So we're saying here that because compound Q has the most branches, the smallest contact surface area, the weakest intermolecular forces, it requires the least energy to break bonds, to break intermolecular forces. By contrast, once again, or we could have said, conversely, we could have said, since S has the fewest branches, therefore the greatest surface area, therefore the strongest intermolecular forces, we can say, therefore, that it requires the most energy to break those intermolecular forces. Note here that only one of these two is required. What's important is that we have related the intermolecular force strength to the amount of energy. And now finally we can answer the question where we can see that since Q requires the least energy, that means that Q would have the lowest or the weakest or the smallest boiling point, which would be 49.7 degrees Celsius, and that then leaves S, which requires the most energy, would have the highest boiling point, which is 68 degrees Celsius, and finally compound R therefore must be left with the middle boiling point of 55 degrees Celsius. As we can see, this is a 4-mark question, and therefore a complete explanation is required. And so you're encouraged to always go through these steps, where the first step is to identify the functional group and therefore the type of intermolecular forces. So in this case, we've said these are alkanes and therefore there are London forces present. The second mark is then for identifying how those intermolecular forces relate to each other. So saying this one has more branches and therefore a weaker intermolecular force, or this one has fewer branches and therefore a stronger intermolecular force. The next thing that must be mentioned, and that is arguably the most important, is relating intermolecular force strength through energy to the physical property that's been requested. In this case, we are saying that since Q has the weakest intermolecular forces, it will require the least energy, therefore Q has the lowest boiling point. Or since S has the strongest intermolecular forces, it requires the most energy to break those intermolecular forces, therefore has the highest boiling point. Question 3.4 reads, a mixture of equal amounts of P and T is placed in a flask and heated to a certain temperature below their boiling points. Assume that no reaction or condensation takes place. The vapor produced is collected in a syringe. Important to note here that neither of these substances is boiling, and as a result it is only vapor that is escaping. It is not the substance turning into a gas. 3.4.1, which compound, P or T, will be present in greater amount in the syringe. And what we need to see here is that we are comparing an aldehyde that has a carbonyl functional group, which we know to be polar and therefore dipole-dipole intermolecular forces, with an alcohol which has a hydroxyl functional group, which we know to be strongly polar and therefore have hydrogen bonding intermolecular forces. As a result of this, we can see that the alcohol has the strongest intermolecular forces of these two, P or T, and since it has the strongest intermolecular forces, it will have the lowest vapor pressure. What that then tells us by contrast is that since pentanol of these two has the weakest intermolecular forces, it will have the highest vapor pressure, which tells us that more vapor is given off by P than by T, and the answer then to 3.4.1, which compound P or T will be present in greater amount in the syringe, the simple answer there is P. Question 3.4.2 then reads, explain the answer to the above question by referring to the types and strengths of intermolecular forces. This is again a similar question to 3.3, where there are a number of things that we need to mention here. And we start out by referring to each substance separately, where we say that P is an aldehyde. We identify the functional group, the homologous series. Since it is an aldehyde, it has a carbonyl group, a carbon-oxygen double bond, which we know to be polar. And since it is polar, the intermolecular forces that exist between these molecules are dipole-dipole intermolecular forces. Then by contrast, we can say that T belongs to the alcohol homologous series because it contains a hydroxyl group, the functional group with an O and H, which makes this molecule very polar. Since this molecule is then very polar, we know that the type of intermolecular forces are hydrogen bonding forces. And now once again, we have started to explain our answer because we have now we've named the different types of intermolecular forces. What remains for us to do is to say that since hydrogen bonding forces are much stronger than the dipole-dipole forces, we can say that more energy is required to break the forces that exist between our alcohol molecules, more energy required for compound T, and therefore, since more energy is required, it will have a lower vapor pressure, or we could have said, by contrast, we could have said less energy is required to break the intermolecular forces between compound P, the aldehyde. Since less energy is required, it would have a higher vapor pressure. Only one of these two methods is required. Once again, important to note the mark allocation here, where there is a lot that needs to be written to ensure that you gather all of those marks in your answer. It's important to note that these questions, or question 3 specifically, follows a similar trend where you're given a number of molecules to compare, and your options will be either comparing molecules of different chain length with the same functional group, or comparing molecules with the same chain length and different functional groups. Either way, in the comparison, the steps remain largely the same in that you start out by identifying the homologous series, therefore the functional group, and therefore the intermolecular forces that exist in each molecule. Once you have identified those, your next step is for comparing, or your next mark is for comparing the strength of each of those intermolecular forces. Once you have compared those strengths, you can then relate it to energy, either by saying that the stronger intermolecular force requires more energy, or the weaker intermolecular force requires less energy, and then your final step would then be to compare it or to relate it to the physical property that you've been asked, whether it's boiling point or vapor pressure, and that's the only way that you can ensure that you get all the marks. Mark 1, identify. Mark 2, compare. Mark 3, relate to energy. And Mark 4, relate to a physical property.